Okay, so I'm just gonna give you a quick little demo about doubling time. So this is a bacteria right here. One bacterium. Let's say that the doubling time for this species is to every 20 minutes. So that means that after 20 minutes passes, then there are 2 bacterium. And after 20 minutes, there will then be 4 bacteria. And after another 20 minutes, there will be 8 bacteria, because in each round of replication, the bacteria, each individual bacteria can split once, creating 2 where there was once 1. So then after another 20 minutes, again, each individual bacterium split, and after another 20 minutes, and after another 20 minutes. So you get where this is going. If we were able to graph this, it would look like, this is what the graph would look like if we were able to see doubling time. Now, the important thing to remember is that bacteria can only reproduce when the conditions are right, when there's enough space, when there's enough nutrients, if they're aerobic, if there's enough oxygen, or whatever their substrate is. And so this is the pattern that we would see in a situation where growth was unlimited, such as in a pork bun. In an environment where growth, or where nutrients rather, are limited, we will see that growth will also be limited, such that initially we see that exponential type of growth as we did in the unlimited situation. But soon we see that there are limits in terms of the amount of space, oxygen, or nutrients. And so the growth phase levels off as we're seeing just as many bacteria dying as are being created. And then soon we will start to see that more dying than being created as we really run out of everything within that culture. So this is what we see in lab. But in the kind of wild environment, we tend to see this type of growth, much more typical in a wild environment, such as some sort of food, such as an infection, that kind of thing.